Welcome to Constant Variables, a podcast where we take a non-technical look at building and growing digital products. I'm Tim Bornholdt. Let's get nerdy.
This Oofda series is sponsored by the Jed Mahonis Group. If your company is struggling to hire or retain developers, try using our team at JMG instead. To learn how working with us can give you ultimate flexibility and save you money, reach out to us at jmg.mn. While you're listening to Tim's conversation with Slater around AI, please take a second to rate and review the show on Apple Podcasts. If you help us out with a rating and review, we'll thank you with a shout out on the show. Visit constantvariables.co/review and we'll take you right there.
Hey Slater, welcome to the show.
Thanks so much for having me.
I'm excited to have you here today. We're talking all things AI and deep learning and machine learning, but before we jump into that, I'd love for you to kind of brag about yourself. Why are you the expert in this stuff?
Oh gosh, I think that'll be pretty tough. So I'll say my first answer is and I actually feel bad about this, but if people really want to know more about me, Google is a really good resource. They can spend the time and they can look through the results. I am mostly the CTO of Indico Data. We're a 70-person AI company that has been around for 8 years, based in Boston, Massachusetts, working on pretty bleeding edge stuff, which we'll get into, probably in some detail later on in the show. I'm also an EIR at 406 Ventures, which is an executive in residence, which means that I do technical diligence on companies to try to understand whether early stage companies have real technical differentiation. And I'm also an active angel investor and advisor in Boston, particularly for deep tech companies where technical execution is a really core part of their business model.
So for a living, you can sniff out if somebody says, yeah, we do AI, and you're like, nah, that looks like just a bunch of if statements.
Fun fact, if statements are the most common kind of AI, and they're called expert systems. But yes, I'm extremely good at that. I think sniff is a nice way to put it, because I would definitely call myself a bloodhound.
Nice. I love that. Well, with that in mind, then let's put those olfactory senses to use here. Then let's break down. There's a lot of terms in this area that I think sometimes non-technical people just lump into one big bucket, and I think it's important to understand the distinction between them. So things like artificial intelligence, deep learning, and machine learning. Do all those things mean the same thing, or are there some subtle differences there we should know about?
Yeah, so there are definitely differences, but I'll say it's not only non-technical people that are lumping these things together. I think it's everyone that is sort of lumping these things together. And I think the problem is that people don't realize that they're highly, highly contextual. And so people often mean slightly different things when they use them. But I'll give, maybe the textbook definition of those three and help you kind of understand how they relate to each other. And I think the hardest one, and this is the one where people get tripped up the most often, is AI and artificial intelligence. And that's because this is the vaguest definition. And very strangely, it's one that intrinsically changes over time. So AI is any situation where you have a computer doing a task that is traditionally, at the time, believed to be a human task, right? So you see why it's this strange kind of contextual definition. So for instance, the example that I always like to use is elevators. Back when elevator operators were the traditional way that you got up and down in an elevator, having that elevator button that you can press that will get you to the right floor, that was AI. Today, nobody would think of that as AI because that's traditionally a machine function. So that's the first thing to say, is that AI is very, very broad, encapsulates a lot of things, and actually what AI referred to 40 years ago, at least in the scientific context, is just very different from what AI refers to today. Importantly, all of that is very different from what I'll call sci-fi AI, right? So that's the Terminator, that's Skynet, right? Sometimes you'll hear that loop in with these other confusing terms, AGI, artificial general intelligence, superintelligence. Maybe put all of that to one side. Those definitions are really primarily science fiction definitions. They're not things that are really based in reality. So there's too much slack in those to have really good conversations about that side of the spectrum, I'd say. So Like, take a deep breath there, and then we can talk about machine learning and deep learning quickly. But does that make sense about AI and why it's such a tough thing to nail down?
Yeah, I mean, especially as I liked your elevator example, because I think I sometimes use that as it relates to self-driving cars. You hear, people before when elevators were first out and they did have people operating them. As soon as there were like operatorless carriages that were pushing or lifting people up and down, people were terrified. They're like, I'm not going to get in an elevator if there's not someone behind behind the board pushing the buttons and operating it. And now, like, when's the last time you were afraid to step into an elevator to I don't think that kind of gets beaten out of you over time, or I guess it evolves out of time after people kind of trust that AI. And I feel like cars are kind of getting the same way, which, we can go with that. I don't want to go way into the category of self-driving cars and the intelligence, but you know what I mean?
No, I think it's a really important point, but let me maybe redirect your thoughts around it a little bit, right? Because I think that is a really common way that people view the transition, but I view it a little bit differently, maybe being on the other side. I think that so much of it comes down to this notion of control, right? And it's not really a question of quality, right? The reason that we like elevators, right, today, and the driverless elevators, if you will, right, is because we have the ability to press the button, right, and door open, door close, and there's alarm, because we've got that really well constructed interface. Right. And that's really what it takes for us to get comfortable with these automated systems, is the notion that I have a really consistent way of interacting with it that I control as an individual. Right. And I think that is, when we look at self-driving cars, that's what's missing. Right. Is, and it's been missing from day one. We haven't figured out how to resolve it. And this is why, really, no matter how good the AI gets, it's not actually going to solve the fundamental problem of, how do you design the human car handoff, right? That's always been the crux of the problem, and it still is the crux of the problem today. I think that's where you see, dramatically more successful executions on self-driving, right? It's things like lane assist. It's things like automated parking, right? Where you've got that really specific, defined kind of interface. But it's a very different kind of experience than I think what a lot of people envision when they think of AI.
No, that's a really great point, because, I mean, it seems like that's every human wants to have control and power. And that might be one reason why technology is so scary to people, is because they feel like you don't have control and you don't have power. A lot of times over the systems that you use, like, take something like Facebook is always something that I'm happy to use as an example to beat up on. So let's just take something from Facebook. Just, you don't have control over what the algorithm shows you. You don't have control over what they basically do with your data or not do with your data, and that stuff can be scary sometimes. And it's the same I think in this application, it's a little more specific of, like, when you talk about like level 5 autonomous vehicles where the steering wheel is optional, that's terrifying to think that there's just going to be a button that you can press and the car just knows what to do. You don't have any way to control something hurling down the road at 80 miles an hour. That is a terrifying prospect for all of us.
Well, I think Facebook is a really great example. I'm glad that you highlighted it, because I think that in so many ways that is the crisis that we're going through with social media today, is that we don't have that control pane, right? We don't have that layer to say, and maybe to be appropriately fair to social media companies, they do have a limit of, like, you can block people and you can report things and you can say, show me less stuff like this. And, you can opt into or out of particular topics. So you do have a bit of an ability to control this AI experience. But I think one of the things that we're finding, and maybe to your other point more directly, this notion of data sharing and privacy, where you're really given no control whatsoever, right? And I think this is something that we're finding is leading to a lot of real struggle and strife, and people do really need these control panes figured out. And so, when we're talking about level 5 things, I think that there's the question of whether that is even something that people want, right? I think that, in a lot of ways, full autonomy, I think, is a stand-in for something, right? Because fundamentally, actually, if you still have a person in the car telling it where to go, right? I mean, that is control, right? And then you still have to have a person there doing it, right? Which is, again, I think that is the point, right? Is that there is always going to be a control pane. It's just a question of what that control pane looks like over time.
Well, I think all of that around artificial intelligence makes sense to me, at least. I'm curious about like introducing these other things like deep learning and machine learning. You know, I'm really curious how you make the distinction and like pluck. Is it kind of like, you know, the squares and rectangles, like where every square is a rectangle, but not every rectangle is a square, sort of a thing? Like,
that's you're in the right ballpark for sure. Yeah. So we talked earlier about, you know, is it AI or is it if statements, right? And this is something that, you know, honestly, even framing it like that, you know, some data scientists get really up in arms about this. This is like a really controversial subject. So if else statements are the original and still to this day most prevalent form of, and I'm going to verbally put quotation marks around this, AI systems, right? But you know, in their defense, right, AI is defined relative to the effect that you are able to have, right? So theoretically, even if you're building that with if-else statements, right, which is called an expert system in the lingo, just so you can recognize it, right? Because they don't want to seem like they're just writing if-else statements, even though that's what they're doing. So they call it an expert system. But, you know, theoretically, if you're able to do that and still have the effect that you're looking for, you know, that's fine. That's an okay solution. The problem is that, and it's actually this kind of very interesting sort of like recursive definition, because a lot of people will say that, you know, when you talk about explainability, and this turns into control a little bit, that writing these if-else statements is a better form of AI than machine learning, which is then sort of the alternative to this, because they say it's more transparent, more explainable, because I can look at these if-else statements. Personally, I don't find that to be a particularly convincing argument. The way that I see things is that even if you can read, because maybe also to recognize the complexity of these expert systems, you know, you might have 1,500 rules chained together. And my argument is that at that point, especially because each of those rules might be incredibly complex, maybe so complex that someone got a PhD for designing that particular rule, you've effectively got a non-deterministic system, right? There's no human being on the planet that understands that, right? Even though theoretically every piece could be understood. And even more importantly, you don't have any real ability to change the behavior of this system over time. So that's expert systems. That's like my quick piece on why I don't like them. Machine learning is the counterpoint to that, right? Which is really saying we're not going to write if-else statements, right? Instead, we're going to say, this is what we're trying to learn. And machine learning is this very generic notion that we're then going to use experimental data to figure out exactly how we should configure this, right? What I would say is that machine learning is any situation where you've kind of adopted empiricism in your system, where you're like, all right, you know, XYZ, we're going to set, you know, we understand what those are, but, you know, ABC here, we're going to learn based on the data. And then machine learning is sort of like anything where you're then going and learning A, B, and C based on some data that you're going to encounter in real life. Yeah. So that's machine learning very, very broadly. And then deep learning is specifically a kind of machine learning that is extremely effective for dealing with unstructured data. Unstructured data being text, video, audio, images, things along those lines. And really what is important about unstructured data and what differentiates it from structured data, which is really anything that fits in a spreadsheet, is just that in a spreadsheet, you know what's important, right? Every column is important. In unstructured data, right, in an image, you do not know what's important. And so you need basically different techniques. Deep learning in this very particular case, you know, happens to be what works very, very well to then learn what is important about the image so that, you know, machine learning can kind of be more effective downstream.
There was one point you made earlier when you were talking about the, like, when you're designing a system with 1,500 if statements and rules that are all interconnected together, and you know that's kind of the point at where we are now with things, and it made me think of an article I read a while back about pencils and how nobody on Earth actually, no one person knows how a pencil is made.
Have you ever heard of a book called The Toaster Project?
No.
Oh, yeah, you absolutely should read The Toaster Project. This was one of the annual books that we read at my school, and a guy tries to build a toaster. He goes out to Walmart or whatever, and he explicitly grabs the cheapest toaster he can find. It's like a $7, one of those white plastic, like spring-loaded toasters. And he's like, I want to make this thing by myself from scratch. And then the cover is this like horrible looking thing. You can't even figure out what it is. It absolutely doesn't work, right? And he spent like, whatever, $1 million flying around the world to mineral mines to buy mica and stuff and try to make potato plastic in his backyard, right? But it's exactly this point, right? You just, you can't make a toaster, right? It's impossible even for the basic things in day-to-day life for us to understand every piece of what makes them from the bottom up.
Yeah. And it's the same with a pencil too. Like no one knows how you can't smelt the lead. Graphite. Thank you. I knew I'd get there. Generating the eraser material, generating the metal that binds it together, like all of that stuff. If you feel overwhelmed already just listening to this episode, just know that you're not alone. Like everyone feels overwhelmed when it comes to technology and at different levels. Like you do have the PhD that may have assembled all of those things together. But again, that took that one person their entire focus for a long time just to be able to do that one thing. And even still, maybe they had to take on faith that certain components of it just worked.
Well, this thing, like that's not how PhDs operate really in practice, right? Is they don't do this whole vertical integration from top to bottom, right? Everyone is dealing with layers of abstraction, right? No matter what you're doing, you're dealing with a layer of abstraction. In fact, to that point of like everything is so complicated, I bet any listener right now, you look around and everything around you is built of things that are, impossibly integrated from 1,000 different sources, right? Like from the monitor, to your headphones, right? The passport on my desk to, even an envelope and the stamp and the glue, right? It's absolutely everything. So, you need layers of abstraction. If you're a PhD, you tend to focus on one aspect and really understanding, everything there is to understand about purple dye in soundproofing, right? And that's very useful, right? But you're not like generally going to do a holistic view of soundproofing, right? It's more specific usually.
Man, okay. So as far as like we've covered artificial intelligence, deep learning, machine learning, and I still feel like there's some practical applications that maybe we could touch on of like, how might you see those three different things being used? Maybe we could start from like deep learning, because I think that one to me, based off your description of it, I think you could pick out a few ideas that would be pretty easy to apply to that. But then stepping out with machine learning and then artificial intelligence as generally speaking, how do you think about helping businesses apply those concepts to something that they might be using as a competitive advantage?
Yeah, I mean, and deep learning definitely is what's getting all of the huge traction today, right? I think there's massive amounts of press around this. When you look at the in very, very broad categories, right? Deep learning is really effective at understanding unstructured content, right? And that's something that we have not been good at historically. So you think, okay, what is the unstructured content in this world that has the most money running through it? And it's ads, right? That's what drives unstructured content today. So when you look at, the most obvious applications of deep learning, where the first generation of just like massive winners came, right? It's ad tech, it's Google, and it's Facebook, right? Which, when you think about it, is actually not that surprising. I think that when you think about AI really, really broadly, though, one thing to always keep in mind is that it's always a human-machine system, right? So it's, the way that I like to think about use cases is, okay, what function in the enterprise, what industry is going to work differently tomorrow? And for me, the next piece is looking at all of these document-based processes, right? When you look at unstructured data really broadly within the enterprise, and, this is what Indico does, right? So I'm sort of putting my money where my mouth is. I do really believe this is where the opportunity is. It's every time a lawyer touches a contract and makes some decision, right? Every time purchasing looks at an invoice and marries it to a purchase order, right? All of these, or, maybe even to get a little bit more interesting, right? When you look at a resume to understand what someone's qualifications are, right? All of those processes right now are happening in these human black boxes, really. The level of introspection you have into them at the enterprise is, Bob saw this loan application and Bob said it was good. And I don't think anyone really wants to operate in a way where you do have things happening in this incredibly manual, incredibly inconsistent way. But at the same time, humans are key to that process, right? Just because, to your point, there's enough complexity that you actually, in fact, legally throughout all of Europe, you need to have a human as kind of an escape hatch for your process. But I think that's a good requirement. I think it makes tons of sense, right? But I think a human checking off a loan pack and saying, yes, this adheres to our process is very different from a human trying to, read 400 pages of content in 30 minutes, which they're kind of asked to do today.
Well, and that escape hatch is exactly like having the elevator stop button there.
Exactly. Exactly.
Yeah, you need that. You do need some human interaction with some of this stuff. But to your point, if you have like using a technical term, a data lake of just millions of photographs, and you want to like pick out which ones are birds, that kind of a problem. If you had a human do it, would probably take someone their entire lifetime to filter through and do it like hand by hand. Where a computer, if you can start to build some models of what do birds look like and feed that to a machine, then that one can pick out and say, well, I'm 95% sure that this is birds, and they can cut down that sample set down to a much more manageable thing that a human can then go through and help to pick out like, no, that's not a bird, that's a car, or I don't know.
So this is actually interesting because I think this is a misconception that a lot of people have. So maybe there's two things. I think one, I think the first notion is a really, really important one, right? Is asking, from an application perspective, from a use case perspective, how do we think about machine learning? How do we think about deep learning in this birds example, right? And I think programming with data is actually a really nice way to think about it, because the important piece, right, your control plane in that case is the examples that you're harnessing for what's a bird, what is not a bird, right? And then here's where things get really interesting, because I think, and this is where, I think people use this as shorthand, but they don't necessarily realize that this isn't actually true, is that, this confidence threshold, right? It's actually not the case that you can meaningfully cut down the amount of review you have to do based on a confidence threshold in a priori way, right? And I think this is something that's both kind of discomforting for people, but also just true, because the confidence level, right, is a statistical average, right? There's no point that you can draw on the confidence level, right, that is going to actually give you some kind of sense of absolution that you're going to get all of the birds, at any level, right? And so, and that may be okay, right? Some people in the enterprise are very mature, right, and recognize that there are going to be error rates, and they're okay with, a model that will occasionally make incredibly confident, incorrect predictions. But, that happens. That happens with all AI systems, period, right? It's not specific to machine learning or deep learning. I think the thing that is a lot more interesting, right? And this is a field called machine teaching, is the notion of, okay, great. I can progressively, improve things over time, right? I can think about maybe as a quick example, right? What actually has a lot more impact is if I give you one image to review at a time versus 50 images to review at a time, that actually makes a bigger difference than whether you use an AI model or not. All right, if you think about that for a second.
So if you meaning the computer or you meaning the human?
The human, right?
Okay, I'm following. So if you it's kind of like with CAPTCHAs when you have 9 motorcycles on the screen and you have to pick which ones are motorcycles and not. Are you saying it's more accurate for a human to filter through it, or I'm not sure?
No. So remember, there is a human filtering through no matter what. There's no world in which any AI system runs in a completely automated way, right? So it's just a question of how you structure that review, right? And again, in practice, when you're dealing with something like a loan application, right, as opposed to birds, you have to recognize that it's actually not okay to have errors go through the system. So a human has to look at everything. But just as a thought experiment, right? Think about the literal application where someone is reviewing whatever portion of documents that we've decided to review. Just say there's some error rate that is okay, right? So even put that to the side. An interface where you have to look one at a time, right, at every image that, say fall below the confidence threshold, there's load time in between each one of those screens, right? And there's a short contextualization for you as a human when you get to the new page to figure out, oh, okay, here's where the image, and it's very, very small, but for every image, it actually adds up very significantly when you're going through thousands of these, right? So compare that to something where you're looking at 50 images at a time. It's actually still, when you're looking at 50 thumbnails, to use the caption example, it's still extremely fast for you to pick out the birds, right? It's actually much, much faster for you to pick out something in an interface like that. It's probably somewhere between 10 and 50 times faster, right, to use that interface, because actually the loading in between screens is going to be the dominant piece. And so I think that shows how the interface actually can have a much larger impact on your end-to-end sort of acceleration than the AI itself. Because imagine an AI, for instance, that is just perfect and handles 80% of all the images for you. Well, actually, you're better off using the better interface with no AI at all, right, than the worst interface with a state-of-the-art AI.
And that's because I think where I'm still slipping is like going through seeing 50 at the same time. Are you saying it's like from a cognitive standpoint, like when one and one keeps going, your brain has a lot harder time of processing through that, as opposed to if you see 50 and you can look and kind of browse all 50 at the same time on your screen? That
is a huge piece of it. Yeah, no, yeah, that's a huge piece of it, but also just the literal technical limitation of needing to have pages load. People actually don't realize this. Like, it takes longer for a page and an image to load than for you to understand what that image is of.
Yeah, that makes sense.
Right? Yeah, just because, the internet can only move images so quickly, right? And for instance, even just thinking more intentionally about what the size of that thumbnail should be so it's getting to you quickly and you can figure out what kind of a bird it is, and it's not, sending an image that is too large. That, again, actually in a lot of cases going to have a larger impact than and sorry, maybe to make the point a little bit more realistic, it's then not really the question of whether you've got an AI that is 0% or 80% accurate, right? But in practice, when you're talking about something that's 80% versus 90% versus 98%, right, it's like actually you're sort of missing the forest for the trees, and it matters a lot more to think about how that's going to be presented to the person, because that's what's going to get you the 10x when you're not going to get that moving from there's a finite plateau to accuracy.
Okay, so like if I'm hearing you correctly, then like I'm again trying to put myself in the eyes of a listener that is trying to understand what are the best applications for this technology and where may we not be good at. I feel like you were mentioning like, there's the bird example, which, depending on context, it all depends on context. But if I'm hearing you right, these technologies aren't necessarily going to say like, if you build some sort of machine learning model to review X-rays to see where, cancer may be developing or not. Like you really, the great, like there's never going to be 100% perfect case where you can say this computer is going to figure it out every single time and you're good to go. The best way to go about doing something like that would be to have the machine help to maybe bring those things to the forefront and still have a human in the process reviewing, what's coming up from what the machine is telling you are potential, positive cases.
You hit the nail on the head. That's exactly right. And I think that is really the biggest opportunity area in AI. It's something that people call augmented or assisted decision making. Right. And I think that's, I mean, I don't know. You said it perfectly right there. I think I'm much, much more excited about this notion there, right, that we keep the human sort of in this center of control. But really what we're trying to do is give them this AI-powered information lens that gets them all the information they need to make that decision 10, 20, 50 times faster than they could get it otherwise. Right. I think that's really where the opportunity is.
Yeah, that makes sense. Like, and that's kind of helping, me think through how all of this technology works too, because, there's been a lot of things that we've covered where I've just been self-reflecting on how this relates to my role as building software and being a mobile app developer. It's hard, like, talking about going down in the stack, like we're not all experts. I know how mobile apps work, but as soon as you get down into like the networking layer, or when you get down into like, flipping transistors on and off, you've lost me. And so that kind of combined with when we were talking about the interface and how humans like to have control and they want to be in charge of everything all the time. But that's never a possibility. Nature is random and chaotic and throws so many different variables into the mix that, no human can be 100% in control of everything. And then we have that kind of fear of knowing that, where, with these machine learning technologies and with artificial intelligence, it's so easy to fabricate a story like Terminator or Skynet, where the computer is going to rise up and take over all of humanity. I mean, I guess that, to me, that feels like we're not even getting anywhere close to being able to do that, right? Like, or are we getting close to doing that? It's not even
the same zip code, honestly, right? The way I would say it's like, maybe it's even right to say, like, it's not even the same technical lineage, right? Obviously actually maybe one thing that I would point out is, I think looking at all of those AI movies, right? If you think about HAL 9000 or, Ultron or any of these things, right? I think that what people often miss in the sci-fi literature, right, is the moral of the story is always that the AI is human, right? Every single time, that's the moral, is like the AI is actually human, right? And I think that's the important thing to know, right? Is like, Skynet is whatever, this analogy for like the capitalist war machine, right? And then the Terminators are these humans with, messy emotions that end up switching sides, right? And I think that's really important for people to realize when they're looking at kind of media depictions of AI. It's really not the same thing that we're building today. What we're building today, in the most effective way, right, is systems that combine humans and AI. And to your point, as a mobile app developer, I think I think this is even broader, right? Hopefully, I think citizen developers and citizen data scientists even are going to be big contributors to this movement, is thinking about what those interfaces of tomorrow look like, right? And today, this technology is still pretty tough to make use of, so it's a lot more prevalent in the enterprise, but it's getting more accessible by the day. So asking, when you're reading news, right, or when you're doing anything really in your day-to-day, watching videos, browsing YouTube, things like that, how might you reimagine those experiences? Because AI has given us, or I'll say specifically, deep learning has given us an incredible set of tools in that space. And right now, the limitation really is on imagining these new experiences with the tools that we've got at our disposal.
When you can see, like, even in while I agree with you, like, there, it feels like a lot of the applications are being used in enterprise. You can look to commercial things that are out there available to the public right now. Like you're talking about, like, looking through YouTube or browsing TikTok. It's like those algorithms that they've got have been trained up so well that it's not necessarily like it's, I guess in the case of TikTok, if you're just swiping through endlessly, like, it's kind of deciding for you. But with YouTube, I've gotten it down to the point now where I open up YouTube and it's got my like 5 things that I like watching, and it surfaces new content in those topics, and it's really, really good at like giving you the choice and saying you probably would be interested in these things. And it's and I also think like another application where I've seen AI and machine learning really interestingly is when you're going through, like in Apple Photos, for example, when you're kind of doing the facial recognition and it's detecting, if this is you or if it's your son or whatever, like some of those things where you're going through and training it up, like it's really interesting to see that process and how much better it gets over time. It does still feel like we're a ways away. I
like the Apple Photos example. I think, and you're going to see great AI technique maybe on the consumer side, right? And what I mean by that is I think there's a really key difference between, are you consuming an AI product built by someone else, right? Or are you creating your own AI products? And I think, those are actually maybe 2 really good examples that you gave where people are sort of blending that line a bit, right? Because you are driving those recommendations. You do have this control pane, right? You are refining this AI model, right? Rather than just being sort of the pure consumer of it. So yeah, I do hope that we start to see a lot more of that breaking through and a lot more of that model being kind of consciously bought into. I think on the flip side, right, you don't necessarily see people like Facebook going in that same direction, right? They've got sort of this very centralize your data sort of notion, which feels, a little bit antithetical to that. But yeah, I hope it continues to get more accessible, as quickly as possible. I think it was only a few years ago, though, where the only folks that could really take a run at this stuff were again, Google and Facebook and Microsoft and, Apple and companies of that scale. And, thankfully, that barrier to entry is starting to come down.
Well, and thankfully, especially I think Google seems to be doing a lot of open sourcing a lot of their work in this area. And I know Apple and other companies put out white papers and things to at least explain what they've learned and help advance things forward. Because I feel like this technology, you could just kind of keep it to yourself and continue to print money time and time again.
So here's the thing is you actually can't. Here's the thing. I'm actually very glad that you mentioned that, because I think AI, this is a way that AI is really changing the world that not enough people realize, is that AI is, by such an absurdly large margin, the most open science on the planet. And I mean, when I say it's absurd, I mean 50% of the papers you see coming out are, have code attached that you can run yourself on your computer, right? Like that. And I mean, the AI community, they'll be like, it should be 100%, right? But you look at any other field and that doesn't happen, right? What people realize, and I think that this is generically true across science, and I think this is a real opportunity. I think that people are starting to realize that this notion of like a wizened old man, like running out of his bath shouting Eureka, right? That's just not how innovation happens anymore. Right. It's this like massive network effect where by sharing research with everyone, right, by putting as much of it out there in as open a format as possible, you really do give people the benefit to move so much faster. It's why AI as a field has moved so incredibly quickly in the past several years. But one of the things that's actually really interesting is that it has kind of destroyed the traditional publishing industry. When you look at the traditional juggernauts, Nature even especially, their track record on AI is actually very embarrassingly bad. Like their retraction rate is really, really high. And actually all of the serious AI work outside of basically specifically Google Brain that just still has a soft spot for nature for some reason. Everyone else has moved off of those. They're just like, Elsevier sucks, right? We hate all of you publications. You're like bad for academia. And these are industry research labs also, because they have actually the freedom to do this for the first time ever. Everything is on archive. Everything is open review. Right? When you look at things that are getting admitted to the conferences, right? You have double-blind review of the papers, without author names associated, so that you really know you're getting the highest quality papers into these conferences. Like all of these things, like if any other field did a single one of these things, it would be, earth-shattering, right? And I think AI really is trying to paint a picture of what a better future for research looks like.
Oh, that's so heartening to hear when in a world where you are, I guess, algorithmically showing a lot of bad news. It's nice to hear that the people creating the algorithms at least are trying to do so in a way that we are being open and more just information wants to be free, right? So
there's a reason that we're so damn good at showing you bad news.
and what's that? It's
the sharing, right? It's being a little glib, but I attribute that openness 100%, to AI's incredibly meteoric progress, right? I mean, we are solving problems as quickly as we can come up with them.
Man, that's exciting. So I want to know, I like asking this question last because I think it's illustrative of just kind of hearing where the experts are actually going to learn more about this stuff. And I know you're probably going to be quick to say research papers, which I'm going to say, okay, I'm not going to do that. But just thinking if you had a friend or somebody that you knew was interested in this subject and wanted to get kind of more of a foothold around what's happening in it, are there any newsletters or podcasts or books or social media group, anything like that you can think of where you would direct somebody to, kind of get involved in a community that's actually working on these problems?
So honestly, unfortunately, this is one thing that I will say is extremely tough in AI in particular, right? The first thing I was going to say is research, and you're right. My answer is research, right? Is research papers, because I think the thing to maybe realize is that, and I know this is a very self-defeating thing to say, AI is not well suited to fast media updates. And I think this is something that's important to note with the extreme speed at which the research comes out, is that when the research comes out, it's not really established. And so there is actually a really, really big wall. It's actually, I think, pretty important if you don't have the background. Like, you can't really dig into the research. It's not going to be very effective. And similarly, the research community is going to be really loath to, put that out in a media context. Only 5 to 10% of all the papers that come out actually will end up being kind of reliably reproduced in a general way, right? And let that soak in, 5 to 10%.
Yeah, that's pretty small.
Yeah, and so I think that is a really, really important thing to know. And if you're an AI researcher, you're of course, that's how it works. That's why we take the time to really dig in and understand these things and validate them, right? I will say that there are individual speakers that I really like. I think Cassie Kozyrkov, puts out some really great content. I think she's Google's, I know she's Google's Chief Decision Intelligence Officer, but I think she's probably one of the best spoken folks in this space. I think Jennifer Jordan also puts out really good stuff, but, there's a real dearth there, right? I wish there is some place that I could point you at. But I think that it's such a deep and contentious field right now. There's, probably 30 times more misinformation than there is information out there. And it's really hard to wade through it if you are not an expert. And I would say AI is a dangerous place to know a little bit.
I think that's so applicable to so much of technology, but I would imagine that's AI in particular. And I think too that's a good point. I've been trying to think of how to phrase this question, and I think you maybe made it make more sense to me in my head for going forward. Is not so much where do you go, traditionally podcasts or whatever to consume the information. It's more of who are the influencers and who are the people that have been kind of been reputably putting out the information that helps you understand what's going on in the world. So I'm glad that you laid out a couple of those people that we can follow to, get a little bit better versed in the space.
Yeah. And then maybe just from an organizational perspective, right? OpenAI, Google Brain, Facebook, right? Maybe to put aside, I'm not saying all of those researchers are perfect people and they might have, their own views, but from an ML research perspective, when you look at the content they put out, and they do occasionally put out blog posts that at least try to be a bit more accessible, it's going to be high quality, right? It's going to represent the real state of AI. That's not necessarily going to be the case with stuff that you read on Futurism or the MIT Press or IBM's blog, right?
Yeah. No, I'm so glad you came on, Slater, because I feel like I know so much more and be a little bit more articulate about the world of artificial intelligence. Where can people get in touch with you or learn more about Indico data as well?
Yeah, absolutely. You can get in touch with me on Twitter, SL8RV. You can read more at slater.website and check out Indico at indicodata.ai.
I love that Slater.website. I love the new top level domains.
I was really happy with that one. I'm not letting that one go.
No. I'm sure if once you buy one domain, you end up usually owning 20 or 30 of them. But there's certain ones that you just.
I found that buying a domain is a really great joke to make in the middle of a conversation, right? If you just think of a really great website.
Yeah, exactly. But then the joke ends up being on you when you keep renewing that domain, thinking oh yeah, I'm gonna do something with that someday.
Oh yeah, no, that's the loser's game. Never renew. Just buy it for 1 year and then done. That's what the joke is worth.
Exactly, and it's worth the $10 or whatever it is for having that. So
exactly.
Slater, thank you so much for joining me today.
Thanks so much for having me.
Thanks to Slater for joining Tim on the podcast today. You can learn more about his company, Indico Data, by visiting indicodata.ai. Show notes for this episode can be found at constantvariables.co. You can get in touch with us by emailing hello@constantvariables.co, or you can find us on Twitter at CV_podcast. Today's episode was produced by Jenny Karkowski and edited by the jubilant Jordan Doust. This episode was brought to you by the Jed Mahonis Group. From applications to infrastructure, from development to support, the Jed Mahonis Group helps businesses get more out of their digital tools. Check us out at jmg.mn or connect with us on LinkedIn.